Hello students, I welcome you all on the platform of InGrade NEET JEE Foundation. I hope you all are doing well. So today our topic of discussion is going to be quantum number. So without any further delay, let's get started. See, in the previous class, I have discussed with you why we need quantum mechanics to specify the properties of your electron. Now we see why we need this quantum mechanics. What is the limitations of classical mechanics that is not explained by this theory. That's why we are coming up to your quantum mechanics and why we dive into the quantum mechanics. See, first thing you have to note here that behavior of matter depends upon motion. Here we all know that if we are talking about matter, then we know that it can be macroscopic and its nature can be microscopic. See, if we are talking about quantum mechanics, then we are going to discuss the nature that is microscopic. Okay, if we are talking about your classical mechanics, hello Akku, classical mechanics talks about your macroscopic particles. Okay, now one thing that you have to keep in your mind is the type of your motion. Let's see, motion can be translational motion, rotational motion, vibrational motion, and your electronic motion. So for each motion we have different type of model. See, for your rotational motion, I am writing. For your rotational motion, we have rigid rotor, for your vibrational motion, we have simple harmonic motion. For your translation motion, we have particle in box. And for your electronic motion, this is your second unit of chemistry, that is your structure of atom, and we are here talking about your quantum numbers. Okay, so I am giving you the brief review why we are moved towards your quantum mechanics, what is the reason of choosing this particular mechanics. Okay, so electronic motion, you are talking about your hydrogen atom. And our topic of discussion is going to be this electronic motion. Okay, these three type of motion you are going to discuss in your higher classes, but for your syllabus, this is your electronic motion. This particular motion is given to you by your hydrogen atom. Okay, so we are going to discuss about this type of motion. So you have to keep in your mind that your hydrogen motion contain electronical motion. Okay, now as I told you that behavior it plays very important role. So for your macroscopic particles, you have to find out the value of determinants, and here for microscopic level we have predetermined values of observables. Ma'am, what is this observables? Basically observable, let's say if you are talking about kinetic energy. For kinetic energy, you have a operator. Let me just give you a quick review of your, let's say if you have to find out the potential energy. So for your potential energy, you have an operator that is minus iota h cut curl by curl x. Okay. So this operator already exists. You have to apply this operator on your motion, or I would say your particular observable, then you will be able to find out the value of your potential energy. But if you are talking about your macroscopic level, here macroscopic level have some laws. Just move to your first slide. This is your classical mechanics. So basically classical mechanics is depend upon the laws of your Newton's laws of motion, and you would say that Einstein theory. So from your laws of motion of Newton and Einstein theory, we are able to find out the value of your macroscopic particles. Okay, but we know that in quantum mechanics we are discussing microscopic particles. So when these laws are applied on your microscopic level, then they are not able to find out the exact value of that particular particle. That's why we have to move towards your quantum mechanics. So this is the reason why we have moved towards your quantum mechanics. Firstly, let's see what's your classical mechanics says. It simply says that it is valid for your macroscopic scale of matter, and you all know that macroscopic means that you can see from your naked eye, simply, which means that it is visible to world. So you are able to see it. Okay. Next says that it is based upon your theory, that is Newton's mechanics, as I told you, Newton's laws of motion, Einstein theory of relativity, and Maxwell electrodynamics. So basically you have these laws of motions and these theory. When you are going to apply this theory over your particular matter, then you will be able to find out its value. It simply says. So here you have formulas. Okay, so you can calculate the value of your observables. This is given to you by your classical mechanics. Now let's move further and see what your quantum mechanics says. It simply says that it is first depends upon your microscopic scale of matter. I hope you got it, what is the meaning of microscopic scale here. Next says it is invisible to world. It simply means that if I am saying, are you able to see the electron from your naked eye? You will say, no ma'am, I am not able to see the electron. That's why it is invisible to world. Next is, this point is very important. It is simply based upon your 6 postulates that are still unproven. Okay, but not yet questions. It means that if we are able to apply that postulates over your particular matter, then we are able to find out its value at microscopic level. That's why these are not yet questioned. Okay. Next is, as I told you, that for your each observable there are operators, or I would say for observable, their observables are determined by applying your predetermined operators. Predetermined operator simply says that they have already a value. If I am saying that kinetic energy, for kinetic energy there exists an operator that is minus iota h cut curl square by curl x square, like this. Okay, that is by 2. Simply it says. Okay, that is corresponds to your wave function for your motion. Now you all know what is your wave function. Wave function simply represented by psi, and psi means wave function. So in the previous lecture, as I told you, that psi itself doesn't carry any physical significance, but if we have the value of psi square, then we are able to find out the probability of electron, or I would say the reason where the probability of finding the electron is maximum. Good morning, infinity word. Now let's see what is the type of motion. As I told you, for your translation motion, particle in box exist. For your rotational motion, here rigid rotor will become. Okay, this is your rigid rotor. For vibrational motion, your simple harmonic motion, that is also known as your SHM. Okay, and for electronical motion, we have hydrogen atom, and we are going to discuss about this. Okay. So, as you all know that we have already discussed it, but still let's see what it says. It simply says that quantum mechanics observables are determined by applying predetermined operator, right, on the wave function that is correspond to the motion. But in your classical mechanics, we have formulas that are used to calculate the values of your observables. Okay. Next, let's see what is the meaning of your operator. Okay. Basically, students, operator is an entity that operates on a function and generate a new function or constant entity. Ma'am, what is its mean? It simply says, let me take an example. I hope you all are familiar with the, this differentiation. Let me give an example of your differentiation. Let's say I have x, and if I am applying an operator that is d by dx, then simply I'll get value that is 1. Okay, if I am applying again this operator over x square, then the value will be 2x. See here, I got in first operator, in first observable, when I operate d by dx over x, then I'll get the constant quantity. But in next step, I got 2x. Here 2 is constant and your x is your next new function. So simply, student, operators are entity. When you are going to apply it over your function, then they are going to generate either a new function or will give you a constant entity. Okay. So as you all know that I am writing the Schrodinger wave equation here. Just wait. As you all know that we have Schrodinger wave equation that is simply represented by your h psi is equals to E psi. So students, it simply says that h is your Hamiltonian operator. This is your Hamiltonian operator. I am writing it here, just wait. Hamiltonian operator simply represent your total energy. Okay, so total energy means here H operator is equals to K plus V, where K represent your kinetic energy and V represent your potential energy. Now I hope you are able to know what is the meaning of your operator. So here you are applying a mathematical tool, that is H, that is your Hamiltonian operator, over your psi. See here, psi is a wave function. I am writing it here. This is your wave function. After applying this operator over wave function, we are getting the value E, that is the value of total energy, and we are getting psi again. See, we are getting the wave function again here. That means such kind of equations are also known as your eigen equations. Okay, such kind of equation where we are getting the wave function, exact the wave function, then that kind of equations are known as your eigen equation. Now let's move further and see the value of your H operator. It is, I am writing it here, minus H cut square by 2m del square plus V. Here I am writing the value of del square here, that is your curl square by curl x plus curl square by curl y square plus curl square by curl z square. Okay, I hope you got it. Now let's move further and see. So up to your 1928 everything was fine. Okay, so as we know that after 1928 Heisenberg's uncertainty principle came, and Born needs to, here Born will come. Born is a name of the scientist. Here Born will come. So Born needs to reinterpret the definition of wave function. So what is this wave function? This wave function, or I would say the reinterpretation definition of your wave function, simply says that psi is not going to tell us about the exact location where your electron is present. As I told you that psi itself does not contain any physical significance. Okay. I am writing it here, no physical significance. Okay. So how we are going to find out the probability of electron? So we are getting the probability of finding the electron by squaring it. Okay. Psi square will give us the probability of finding the electron. Okay. So it tells us about the probability of finding an electron within a region, or we can say your probable distribution. Which one? One wala? Preeti, which one you are saying that you are not getting? This one? Which one? Please write something about the topic that you are not getting, so that I'll be able to understand it. Okay. Now let's move further and see why we need the quantum numbers. So basically your quantum numbers give you complete information about an electron, or you can say that orbital in an atom. Basically your quantum numbers, that is represented by 4 quantum numbers. You have 4 quantum numbers. One is going to be your, just wait, principal quantum number, that is represented by n. Next is going to be your azimuthal quantum number, that is represented by L. Next is your magnetic quantum number, that is represented by Ml. And last but not the least is going to be your spin quantum number, that is represented by Ms. Okay, one more thing, that from this we are going to find out the value of this particular wave equation, will give you the value of M, L and N. Okay, we are not getting the value of quantum number, that is your spin quantum number, from this wave equation, but we will get the value of M, L, N. We are going to discuss about this topic in your JEE Advanced. So now let's move further and see your what is quantum numbers. Okay, first we are going to discuss about your principal quantum number. So you all know that your principal quantum number will give you the size, and it simply represent the size, and you can say the large extent with which your energy is related to particular orbit. Let's say it is n is equals to 1, then you can say, ma'am, it is represented by k orbit. If n is equals to 2, it simply says that it is L. N is equals to 3, it is M, and so on like this. Okay, so basically orbital is a 3D space. Okay, there is a difference between your orbit and orbital, and we are going to discuss about it. Here orbit is different and your orbital is different. So orbital is a 3D space. Okay, if I am talking about orbit, let me like here. So orbit is 2D representation, but your orbital will give you 3D representation of a particular orbit. Okay. Now let's move further and see for your hydrogen atom, or you can say your hydrogen like species, energy and size of orbital depends only upon your n. One more thing you have to keep in your mind. Let's say if I am drawing the size, just wait. Just wait for a moment. Let's say this is your nucleus, okay, and this is your, this is your n is equals to 1. It simply represent your K shell, okay. If you have n is equals to 2, then you are going to simply write it like this. This is your n is equals to 1 and this is n is equals to 2. So this is your K shell and this is your L shell. See here, size is increased as here value of n is equals to 1, here n is 2 and n is 3. Let me represent here also. Just wait. So here you can see this is going to be your K shell, this is your L shell and this is your M shell. So this is your K shell, this is L, this is M and this is your N. So this is, so as the value of n is increasing, so you can say that the probability of finding the electron is also getting decreasing. How? See here, the force of attraction between the nucleus and the electron is maximum where value of n is small. So as you know that as we are moving ahead, so the tendency of attraction between your nucleus and the electron is getting decreased. Here you can see that the force of attraction between nucleus and the last orbit is going to be decreased as compared to your n is equals to 1. Okay. So this says for your hydrogen and hydrogen like species, the energy and size of orbital depends upon n. How? So in the last lecture, as I told you that if n is equals to 2s, or I would say n is equals to 2, so for n is equals to 2, value of L will be, you can say here 2s exists, okay, and 2p exists. So both will be lie over your same energy level. So 2s and 2p subshell will lie over your same energy level. It's like this. So if n is equals to 3, let's say n is equals to 3. For n is equals to 3, you are saying ma'am 3s exists, 3p exists and your 3d exists, right? So for these three energy levels, we have the same value of energy. So it simply says, now come and see this point, it simply says that you for hydrogen like species, energy and size of atom that is completely depend upon n. Okay, you can see here 1s going to be, 1s is your less than 2s, that is equals to 2p. Next will come your 3s, that is equals to 3p, that is equals to 3d, and so on. But this is going to be true for your hydrogen like species, or I would say single electron species. Okay, this is your for single electron species. This is not going to be true for your multi electron species. Okay, keep this point in your mind. Now let's move further and see. It indicates the distance of electron from the nucleus. As I told you, here, just wait. Here you can see the distance between the electron and the nucleus is getting increased as the value of n is getting increased. Okay. Now let's move. See the next point which is important. I am writing it here star, which means that this important. It simply says as the value of n increase, energy will be increased. Okay. Now see the next point. You have to remember this point. It simply says if you have to find out the total number of electrons, then how you are going to find out? You will simply apply this formula which says 2n square, and total number of orbitals, that is equals to your n square. Okay. देखो, let me give you an example. If I am saying that n is equals to 1, okay, so number of orbitals, that is 1 square, so that is equals to 1. Okay, for n is equals to 2 square, that is 4, right? And number of electrons, I am writing it here, 2n square, it simply says 2 is equals to 1, 2. And you know that for 1 we have only one subshell, that is your s. Okay, this is going to be your s orbital, and we know that here 1s will come. Okay, and how we are going to fill this? Like we all know that in next class I am going to tell you how we are going to fill the electrons in a particular orbit. But here I am just giving you the brief idea that one orbital contains 2 electrons. Okay, so here 2 electrons will come. Now let's move and see for n is equals to 2. So number of electrons will be 2 into 4, that is 8. And we all know that if value of n is 2, we have s shell, that is you can write it like 2s, and the next one is going to be your 2p. So if I am writing 2s here, so this is going to be 2p, that is again divided into 3 parts. So here one is your, this is your 2s, this is your 2p. As I told you that one orbital contain 2 electrons, so here 2 electrons will come, here 2 electrons will come, and that's how you can see here total number of electrons will be equal to your 8. So that's how you are going to apply these formulas over here. Okay, 98 gamer, I am going to tell you the difference between orbit and orbital. Just wait for a while. We are discussing here quantum numbers, Preeti. Let's see, move further and see next slide, that is your azimuthal quantum number. Okay, that is represented by L. So the value of L depends upon the value of n. It simply says that its value will be lie between 0 to n minus 1. Let's take an example of n is equals to 1. So if value of n is 1, then I know that value of L will be 1 minus 1, that is equals to 0. So for n is equals to 1, value of L will be 0. If I am saying that n is equals to 2, then you know that here 0 to n minus 1. If I am applying this formula, then I can see here 0 will come, 0 to here 2 minus 1, that is equals to, I am writing it here, 0 to 1. Okay. So we can see that value of n is equals to 2, value of L will be 0 and 1. Okay. And if value of n is 3, then value of L will be 0, 1, 2 and so on. Now one important thing you have to keep in your mind, I am writing it here. If L is 0, then this is known as your S subshell. If value of n is 1, this is known as your P subshell. If value of L is 2, then this is known as your D subshell. For 3, this is going to be your F subshell. Okay. Here I am writing it here, subshell. Okay. let's move and see the next point, which simply says that if gives the name of the subshell that is associated with your each energy level and the number of subshell within an energy level. Okay, so it simply give you the name of subshell. As you can see here, 0 is S, for 1 N is equals to L is equals to 1, P subshell exists, 2 D subshell exists. Now one more thing, let me write it here, just wait for a minute. Next, see the next point, which says different value of L indicates the energy and the shape of the orbitals. Here you can see the different value of L's and it is indicating the different value of energies. Okay, and the shape also. Let me write the shape here. For 0, this is your S, and S is spherical in shape. Okay, this is going to be spherical in shape. For 1, this is your P, and value of, or I would say the shape of P orbital will be, it's like this. Okay, for 2, this is your D, and we will see the shapes of D orbital. Here I am giving you the review, quick review, like how you are going to draw it. It's simply like this. Okay, like this, double number. Okay, next is going to be F. Let's see here, let me draw it here, dxy. Just wait for a minute. I'll draw it here. If this is your x axis, this is your y axis, then this is known as dxy. If this is your x axis and z, then this is known as dxz, and this is known as your dyz, and this is known as your dz square, and this is known as dx square minus y square. We are going to, good morning Aman, we are going to discuss about it. Just move for a 5 minutes, just wait for a 5 minutes and see here. For your azimuthal quantum number, the value of energy of subshell will follow this order, which simply says that energy of S is less than P and P is less than D, and value of D, or I would say the energy of D, is going to be less than your F. And what is the reason? Simply the reason behind the shape. Okay, next says that the total number of orbital in a shell, that is equals to 2L plus 1. Okay, let's say your value of L is equals to 0, then the number of orbitals, if you want to calculate, and this is coming out to be 0 plus 1, that is 1, which is simply represented by S. Okay, if I am saying that value of L is equals to 1, then how I am going to calculate it? It is very simple. 2 into 1 plus 1, that is 3. So what are these subshells? These are going to be your Px, Py and Pz. Okay, so if you want to draw the shape of Px, Py, Pz, then how you are going to draw it? Just wait, let me draw it here. I am drawing the shape of Px, Py, Pz here. Just wait. let's say this is your x-axis, this is your y-axis, and this is your z-axis. Okay, so px will be like this. Okay, this is x, this is y, this is z. This is going to be your pxy, and pz will be like, I am drawing it here, this is your pz. Okay, this is px, this is py, and this is going to be your pz. So these are the shapes of your px, py and pz. Yes, exactly. Now see, next says your total number of electrons in a subshell, that is equals to 2 into 2l plus 1. So how you are going to calculate it? See here, as we know that if value of L is 1, then the total number of your subshells, that is equals to 3. So the total number of electrons simply 3 into 2, that is equals to 6 electrons. So if you want to add the number of electrons in your p subshell, then it will be like, this is going to be px, this is going to be, I am drawing it here like this. Let's say this is like this. This is, let's say this is your px, this is your py, this is your pz. Then it will be like this. Okay, that's how you are going to add the electrons in your subshells. Okay, now let's move further and see one more thing. I am writing it here, just wait. If the value of, let's say, L is 0, okay, then total orbitals, I am writing it here, total subshells, and here total number of electron. Let's say L is 0, then you all know that formula will be, I am writing the formula here. So 2 into 0 plus 1, that is equals to 1. So number of electron will be 2. Okay, if L is equals to P, then we know that for L is equals to P, or I would say L is equals to 1, 2 into 1 plus 1, that is equals to 3. So number of electrons will be 6. Okay, for L is equals to 2, that represent your D subshell. Energy is directly proportional to your principal quantum number, that is your L. Okay, so that will be equal to 2 into 2 plus 1, that is equals to 5. Okay, so the total number of electron will be 10. That's how you can calculate the value of L is equals to 3 and so on. Okay, let's say this is 7, so the total number of electron will be 14. Okay, that's how you can calculate the total number of electrons in a particular subshell. Now let's move further and see the next point, that is your magnetic quantum number. So your magnetic quantum number simply helps you to identify the value of L's, or I would say the shapes. See, simply this quantum number depends upon your azimuthal quantum number, that is L, and it gives you the orientation of orbital in your space. Okay, so value of your ml depends upon L, and it is lie between minus L to L. Let's say if your value of L is 0, and if you want to calculate the value of ml, it simply will be 0. Okay, and it will represent your S subshell. And if value of L is 1, then the value of ml will be minus 1, 0 and 1. So what is minus 1, what is 0, what is 1? See here, this is like I am drawing it here. Let's say 1 is your minus 1, 1 is your 0 and 1 is your 1. So students, many times in the NCERT book you have seen that 0 simply represented by PZ, this is represented by your Py, or you can see here Px. Okay, Px, Py, Pz. So these are going to be the shapes of your Px, Py and Pz. Okay, now let's see the next value, or I would say the next point, that is formula. You have to remember this formula. Next is It indicates the number of orbital and the orientation in 3D space, and we have discussed this point. Next is, in the absence of your external electric field and magnetic field, the orbitals having same value of n and l but different value of m have same energy. See, in the absence of external and magnetic field, if these two fields are not present, then the value of your n and l will be same, but the value of m will be different. Value of n and l will be same, but value of m will be different. So these type of orbitals that have same energy levels are known as your degenerate orbitals. And see in the slide number, that is your 14. As I told you here, you can see that for your hydrogen like species, the value of 2s and 2p is same, right? Or I would say the energy level, value of energy of 2s and 2p is same. You can see here both have n is equals to 2, same value of n, right? But value of l is different. For s we have 0, and for, I am writing it here, this is going to be 0 and this is representing 1. These are the values of your l. Okay, now see here, these two have different value of ml, and you all know that 2p will be existing like this. This is going to be, let's say, 2p y, this is going to be 2p z, and this is going to be your 2p x, right? But for 2s, only 2s orbital exists. So these two have same value of n, different value of l, or different value of ml, but these two are lying at your same energy level. That's why these are known as your degenerate energy levels. So different orbitals having same value of energy and lying at same energy levels are known as your degenerate energy levels. I hope you got it. Now let's move further and see the point. As you all know that if value of l is 0, then value of ml will be 0 and your orbital will be s, and your s orbital is spherical in shape. You can say that here it is non-directional. I am writing it here. Just wait here. This is your non-directional. And one more thing, many times a word is used, that is your InGrade. Okay. See here, value of L is 1, then ML will be -1, 0, 1, and your orbital will be Px, Py, Pz, and as I draw the values of Px, P, or I would say the diagram of Px, Py and Pz. So one thing that you have to keep in your mind, that this is your directional in nature. Okay, or you can say that G-rate. Okay. Next is, for value of L is equals to 2, 5 orbitals exist, that is dz square, dz square y square, dz square minus y square, dxy, dyz and dzx. So keep one point in your mind, which is dxy, dyz and dzx. These orbitals form along the, in between the axis, in between axis, and your dx square minus y square and dz square, these are lying on the axis. Okay, you can see the shapes here. This is your dxy, this is xz, and this is your dyz. So these are just, so these three are lying between two axes, and you can see here these two are lying between, sorry, above the axis. Okay, so these are the points that you have to keep in your mind. Okay, see, I am representing the value of dz square. See here, you can see the electron, these particular lobes are representing the value of your electron density, and you can see here, there is here electron, just wait, electron density is present here, electron density is present here, here also electron density is present. How I'll explain you, the shape of your dz square is like cone. If you have seen the cone like structure, it's simply like, just try to draw the cone by using the page. After that you will be able to find out the draw the value of this, or I would say the shape of dz square. So here you can see in this part the electron density is present, that's why here the nodal phase is 0. But it is not always important that the value of nodal plane will be always 0. If I am saying, I am representing the meaning, let me tell you the meaning of node. Node simply represent the area, or I would say the point where the probability of finding the electron is 0. So your total number of nodes will be given by the formula, that is n minus l minus, that is n minus 1. Okay, and your radial node will be equal to, that is equals to n minus l minus 1, and angular node, that is equals to l. Let's say you have to calculate the value. Let's say if n is equals to, I am using the different pen here. Let's say n is equals to 2. Okay, exactly, conical node, exactly, you are right, n is equals to 2. And see here, if I want to calculate the number of nodes, how I am going to apply it here? So total number of node, that is equals to 1. Okay, and radial node will be equal to 2 minus, let's say if l is 1, then your angular node, that is equals to l, which represent p. Okay, I am writing it here, it simply represent p. Okay, now if you want to calculate the radial node, that is equals to your 2 minus 1 minus 1, which is simply equal to your 0. So you can see here only your angular node is present, radial node is 0. So if you want to calculate the total number of node, then that will be 1. Okay, so total nodes that is equals to 1. Okay, so if you want to draw it, it will be like this is going to be 2s, and if I am drawing it here, just wait. So this is going to be the area, student, where the probability of finding the electron density will be equal to 0. Okay. Now let's move further and see the next point that is important for your azimuthal quantum number, which simply says orbitals with same n and l but different ml have same energy. Okay, we have discussed this point. Next is this occur when no external electric and your magnetic field is present. We have already discussed this, and these type of your orbitals are known as your degenerate orbitals. Okay, what are degenerate orbitals? We also discussed this topic. Okay, now let's move further and see your spin quantum numbers. In spin quantum number, students simply represent your spin of a particular electron. So your electron spin, let's say this is going to be your electron. If I am saying, let's say this is your electron. So this electron is revolving around its own axis. So spin can be like, one is, let's say, just wait. Let's say this electron is moving in anti-clockwise direction. Then in anti-clockwise direction, its spin will be represented by your minus half. Okay, and let's say I am writing it here, anti-clockwise. And if this electron is revolving in clockwise direction, then it is represented by your plus half. Okay, it is very simple. So electrons spin on their own axis and their direction can be clockwise or anti-clockwise. So they have two values of ms, that is plus 1 by 2, that represent up spin, and next is going to be your minus 1 by 2, that is representing your spin down. Okay, so you all know that each electron can hold only 2 electrons, so each will have opposite spins. Now let me tell you one more thing that is important. If I am saying this is an orbital and you have to fill the electrons here, so how you are going to represent the spin? So if I am saying that one student is saying, ma'am, I am going to represent the spin like this, I said okay. Next one is saying, ma'am, I am going to represent the spin like this. And next says, ma'am, I am going to represent the spin like this. Now you tell me what is going to be the exact representation of the electrons that is present in this particular orbital. Give me the answer. Okay, graph say. I'll explain the number of nodal planes that is represented by graph also, but that will be in the next lecture. Now tell me the exact representation of the 2 electrons that is present in this orbital. Okay. See student, this is going to be the exact representation. This is not applicable, this is not applicable. As I told you, both the electrons can have 2 spin, one can, and both the spin in maybe, or I would say the both spin will be like this. One is going to be 1 by 2 and the next one is going to be 1 by 2. So this can be represented by, one is going to be upward and the next one is going to be downward. Okay, yes, exactly, angry. आपने सही बोला है. This is going to be the exact answer. Okay, I hope you got it. Now see the energies of orbitals. So how you are going to represent the particular energies? As I told you that if electron is present only in hydrogen atom or hydrogen like species, exactly Pauli's exclusion principle. So your value of energy for orbitals that increase in your hydrogen atom will be like this. You can see the structure here. It's simply representing the energy levels of your hydrogen like species. I am writing it here. This is for your hydrogen like species. Okay. and we have discussed this point so many times, that your value of n will be, if value of n is 2, then orbital will be 2s and 2p, and both will lie at same energy level, and it simply means that they are degenerate energy levels. Okay, next point is, if the orbitals having same energy, then they are known as your degenerate orbital. See here in this graph, this particular graph represent the energies of your multi-electron species. This is representing your multi-electron species energy level, that is 1s is less than 2s, that is less than 2p, and so on. So how we got this, we will discuss in the next lecture. So let me just conclude what we have discussed here. Okay, we have discussed the shape of orbitals also. You can see the slide number here. I guess this is going to be a slide number 21, I think. Yeah, okay, this is 19. We have discussed the shapes of orbital here. This is going to be your S shape, that is spherical. This is the shape of your d orbital, that is double number. Next is going to be your p orbital, that is dumbbell. Okay. Now let's move further. So with this, I am winding up the session. So I hope you like it. Thank you and have a good day.